Okay, this is the starter for the lesson on rounding decimal places. I'm just going to whiz through the results of what should happen as we went through it. Sorry about that. The aim is to be able to actually say which number on the end of the line is actually the number closer to. So question 2, let's have a look. We're looking, where is it on the number line between 100 and 200? Well, we know halfway is 150. 146 is less than 150, so it's on the closer end to 100. Question 3, between 1,000 and 2,000, halfway is 1,500. 1,746 is bigger than that, so therefore we are closer to 2,000. And notice that if we're doing it on multiples of 10 and powers of 10, that what we do is we take the lower number, put the 5 on the next digit. So the lower number, put 5 on the next digit to the digit being written, and we can actually then say what is the middle. So between 1,000 and 2,000, 1,000 has a 1 in the thousands place, put a 5 in the hundreds. 1,500. It is only true when you're doing it for tens, but we're finding halfway. So this important to look for is the halfway point. Okay, so that's the important thing when we're rounding, because it is possible to actually round to the nearest 5 number. So you'd put 5 and 10 either side of the number, or multiples of 5 either side. Halfway between 5 and 10 would be 7.5, and you compare to that number. Here's the sneaky one that catches people out, and it's because it's got decimals in it. The first thing to think is these numbers have different numbers of decimal places, so I need to know what these look like with the same number of decimal places. Decimal places are the ones after the decimal point. So the largest number of places is 3. So let's just put in the extra places. We've now got two numbers with 3 decimal places. What's halfway between 0.300 and 0.400? Well, same rule we did before. Go to the first digit, the 0.3, put 5 in the next place, and we want 3 decimal places in every question or for our working, so we can compare the numbers. Having put the right number of places in, 367 is bigger than 350, so it's on the right hand side, and therefore it is closer to 0.4. It's not 0.400. We don't put the 400 because if I wanted 0.400 to be what's the number, well, I've got a better number to look at, which is 0.367. Okay, so if we wanted 3 places, I would quote the more accurate version of the number. But when we're doing just to the nearest decimal, the first decimal number, you only quote that first decimal number. Okay, scroll on. And then we've got our blue. So same idea. We've got 2 decimal place, or 2 places in our decimal numbers on the scale. So put an extra number on the end, an extra 0. 0.070 is the same as 0.07. Look at the right in the middle, 0.07. And put a 5 after it to find what is halfway between 0.07 and 0.08. Look at the 0.073. That's smaller than 0.075. So we're closer to 0.07. Again, notice we do not quote this extra 0. That's there to help us think. That's the only reason that point is there. So that 0 is to help thinking. Next part, 8.65. This time I've got 2 blanks. Well, if I'm rounding to the nearest whole number, which is what the 9 indicates, the number before it is 8. Halfway between 8 and 9, 8.5. The decimal value, and then put a 5 in the next place, so it's 8.5. 8.65 is on the right hand side, so it's closer to 9. Okay, so just to bring in some descriptions, there's two words that mean the same as about, but they have different meanings mathematically. An approximate answer is close to the actual value. We actually know that value. So we actually know we know the actual number. When we estimate, we use approximate numbers or approximate values, and we do some form of calculation, probably the correct calculation but with approximate values, to give a rough idea. Now the reason I'm using the word rough here is a close says it's a good number, very close to the answer. Rough means we know what sort of size it is. So that's the two differences. Approximate means we are close to the actual value. Estimate means we know how big the actual value is because we've used approximate values to give us an idea. So the